Now we're going to talk about something new called a piecewise function, and it is exactly how it sounds, right? Yesterday we talked about this recycling problem of how, okay, so this line does it pretty well to start, this line does it pretty well second, but there's no way to show all the data, right? It's in different pieces. So that is what this is, different pieces of the graph. So if you look, same type of thing. We have a certain trend for the first 5 hours with temperature. Obviously, temperature doesn't increase overnight all the time, and then it normally cools off, right? So different pieces of the graph. One thing you notice, one thing you wonder, maybe where this is at and what time of year, some things that you could ask about that. But let's dive right into it here on page 86. It says approximate the percentage recycled each year with a piecewise linear function by drawing between 3 and 5 line segments to approximate the graph. Okay, so I need to decide now how many different pieces of this graph I should, this is the same one we talked about yesterday, how many different pieces of this graph I should have. Okay, so we thought this first one was pretty close, right? Pretty linear. So maybe here's a way we can demonstrate to start. It says 3 to 5. Well, there's one. Maybe even go up a little further, because then it looks like it goes down a little bit. Something like that. And this one, I think we can generalize the whole thing. Something around those lines. That might be a little high. It seems to have a lot more dots below it than above it. And then it trends down again. So everybody might have a different line, and that's fine. So I have 1, 2, 3, 4 different pieces. You might have 5. It's okay. So it says find the slope of each piece. Okay, so let's look at line 1 here. So I'm going to need a couple of these points then. And we'll figure out the slope. Maybe I could use this one. Looks like it goes through this one exactly. So that's 1995, and what percent do you think that is? I think that's 22%, or should we just call it 21? We're going to approximate. 21.2? I don't want decimals. That sounds like a nightmare. Should we call it 22? 21. Call it 21. All right, we're going to call it 21. Okay, how about this dot? Right here. This one looks like it goes through right here. 95, 94, 93. That would be 92. 17%. All right, so our slope then, subtract the y's. 21 minus 17 is 4. 1995 minus 1992 is 3. So 4/3, or 1 1/3. That would be percent per year on all these. Percent recycling per year. So an increase of 1%, a little over each year. All right, line 2. Line 2 is this guy. Okay, so why don't you give me a couple points here? This would be 95, 96, 97, 98. We're calling that one 21% still? 22. Oh, we're going 22 with that one. Interesting. Okay, this one would be about 96. What's that percent? 22. That's 22, and this one's 22? That can't be it.
Makes perfect sense.
You'd have to call this one 23 then, I suppose.
2.5.
Could do decimals. I don't really want decimals. We're just estimating these points. So 22 minus 23 is negative 1. 1998 minus 1996 is 2. Why is this one negative? The line goes down, right? So now it's going down a 0.5% per year. People were recycling a little less. Then it goes back up here. Again, find a couple points that it goes through. This seems like a good one. I just said that was 98 and 22. Let's use that again. Need one more point. It's pretty close to that one. 2010 and what percent? 26, all right. Subtract the y's. 26 minus 22 is 4. 2010 minus 1998 is 12 years. Again, that is positive slope. It is increasing about 1/3% of a year. And then line 4. Again, finding 2 points. Let's do 2011 and what do you think that dot's at 2011?
26.
26. And then 2012 and 2013. And I need a percent for 13 there. 25? Sure. 25 minus 26 is -1, and then 2 years again, and it's again -0.5. Again, the line goes down. We should have known that it was going to be negative. All right, page 87. The graph shows the amount of water in the tub in gallons as a function of time. Add labels to the graph. Okay, so what gets graphed on the bottom, what gets graphed on the top? Well, normally time is always going to be here, so this is going to be time in minutes, which means gallons of water. It's going up on the y-axis. When did she turn the faucet off? Yeah, when the water stopped filling up, right? So that would be 6 minutes into this thing. Turn the faucet off. How much water was in the tub when she gave her dog a bath? Assuming you shut the water off when you start giving your dog a bath. 24 gallons? How long did it take for the tub to drain?
9 minutes.
Okay, so here it's full yet. Then it looks like I pulled the plug at minute 18 and it's empty at 30. 12 minutes. 30 minus 18, 12 looks good. At what rate did the faucet fill the tub? Okay, well, how many gallons did it go up and how many minutes did it take? How much? Yeah, it went up 24 gallons in 6 minutes. That is 4 gallons a minute. And then it drained. 24 gallons drained, and how many minutes did you say that took? In 12 minutes. So how fast did it drain? 2 gallons a minute. Yep, 24 divided by 12. All right, the last one. The graph shows the speed of a car as a function of time. Describe what a person watching the car would see. So look at that graph. What would you see? Well, it looks like the car is starting, not moving. And what does this represent?
Speed.
Yeah, increasing speed of the car. Cars speeding up. What happens here? What do you mean it waits? Does it stop?
Yeah.
It's still pretty high on the speed.
Oh,
Right, stopped is here.
just steady
Yeah, so let's say it's going up to 50 miles an hour. It stays at 50 or whatever for a while. So this is constant speed. Still moving though. And then what happens here? Going slower. Decreasing speed, slowing down. However you'd like to say that. Okay, so again, just watch the labels. That will be a common answer that people will say that car stopped. That is not the case. All right. Take a look at your homework then, starting on page 91. Only 4 questions today. This first one's a description. Not speed over here, it's how far I am away from home. Okay, still time on the bottom. Question number 2, I think you can handle. 3 is asking about a bike trail. Yeah, and 4 is not asking you to solve. It's just asking what does this mean in this situation. I think you can handle that as well. So just those 4 questions, guys, for tomorrow.